Hello everyone. Last lecture we covered the concept of nested data structures. We are going to get today's lecture started by getting practice for lookups with nested data structures. In this video, I'll be covering problem number 3 from today's lecture worksheet. Let's get started by going through the code snippet at the beginning of the problem. We are defining a dictionary called Webster, within which we have a couple of lists and another dictionary as values. Then we are defining a list called loony_list, which contains two integers and the Webster dictionary as items. After that, we are appending loony_list within itself. It is kind of crazy to think about. Following that, we are inserting a new key value pair into the Webster dictionary, where the key is string L and the value is loony_list. Then we are defining a function foo, which includes a parameter everything. Within the function, we are looking up everything of z and assigning that value into a variable called final_letter. Then we have a print function call where we are using 4 question marks to represent the argument. We'll be replacing those 4 question marks with each of the lookup operations as part of the below table. Finally, we are invoking foo function by passing loony_list as argument. Recall that whenever you are executing a function call, you have access to the local variables which are part of the function call frame and also access to the global variables which are part of the global frame. This is an example of a crazy nested data structure. Practically, nobody will create such a nested data structure. We are just going to use this nested data structure as an example to solidify our understanding of lookup process with nested data structures. When you learn the concept of objects as part of the next lecture, you'll be able to create such a diagrammatic representation of nested data structures. For now, you just need to use the provided diagram in order to answer each of the lookup questions as part of the table below. I would encourage all of you to pause the lecture video here and try to go through the lookup operations on your own and then come back and watch me go through each of the sub-problems. Let's get started with sub-problem number 1 here. It's asking us what is loony_list of 1. Loony_list is part of the global frame. Let's keep track of the arrow from loony_list variable box that's taking us to this particular list over here. Let me write down the index positions. The positive index positions are going to be 0, 1, 2 and 3. The negative ones are going to be -1, -2, -3 and -4. I'm going to keep striking out each of the indexing or lookup operations within the square brackets as part of the expressions as we keep covering those. Loony_list of 1 is simply going to be the integer value of 9. Subproblem 2 is asking us what is Webster of a of -1. Let's keep track of Webster. Webster is taking us to this particular dictionary over here. How can I say this is a dictionary? That's because this is represented using a vertical box. Python Tutor uses vertical boxes to represent dictionaries and horizontal boxes to represent lists. We are going to follow the same notation. So Webster of A is going to be this particular key over here that is taking us to another list. Let me write down the index positions for this list. Those will be 0, 1, 2 for positive index positions, -1, -2, -3 for negative index positions. So what is Webster of A of -1? That's going to be the value ADA, correct? Be careful here. You shouldn't be adding the double quotations around ADA. That's because we are passing this particular lookup as an argument for the print function call. Recall that the print function call formats the provided string argument and removes the quotations around it. Let's go through subproblem number 3. It's asking us what is Webster of Z. Webster of Z is this particular key over here, which is taking us to another dictionary. Let's mark off that particular lookup. Webster of Z is this dictionary. We want Webster of Z of name. That's going to be the value zebra here. Let me go ahead and write down zebra as part of subproblem 3 within the table. Let's go through subproblem 4. What is Webster of L? Webster of L is going to take us to this list over here. Webster of L of 1 is simply going to be the value 9. Observe that we now have two different paths for arriving at the data item 9. When you have a crazy nested data structure, there are going to be multiple different paths for arriving at a particular value. We'll be covering a couple of examples for arriving at the data item 9. We already went through subproblem 1 and 4, which enable us to do that. Let's go through subproblem number 5. It is asking us what is Looney underscore list of 2. Looney underscore list of 2 is taking us to this particular dictionary on the top. From that, we are looking up the value of the key B. Key B is taking us to this new list here. Let me write down the index positions. Those are going to be 0, 1 and -1 and -2 for negative indices. Looney underscore list of 2 of B is this particular list. Within that, we want the item at index position 1. That's going to be the value debug here. Let's go through subproblem number 6. Subproblem number 6 is asking us what is Looney underscore list of 3 of 1. Looney underscore list of 3 is going to be a self-reference to the same list itself. Then you can cross out that particular indexing because it is just taking us back to the same list, which is given by the variable Looney underscore list. So what is Looney underscore list of 3 of 1? That is simply going to be the integer value 9 here. Let's go through the subproblem number 7. Subproblem number 7 is asking us what is everything of something. Everything is part of the foo function called frame. Let's track the arrow that is leading us to this particular list over here. What is everything of 3? That is simply going to be the same self-reference back to the same list pointed to by everything variable. So I can comfortably strike out any of the indexing which uses the index 3. After that, you have everything of 2. What is everything of 2? That is taking us to this particular dictionary on the top. And then from that, you're trying to look up the value of the key Z. So the key Z is taking us to this other dictionary over here. Then we are trying to look up the value corresponding to the key kind. That's going to be the value mammal here. So the answer for this particular subproblem is going to be mammal. What is final underscore letter of name? Final underscore letter is part of the foo function called frame. Let's keep track of the arrow that's taking us to this particular dictionary over here. The key name corresponds to the value zebra, so I can strike out the lookup for key name. Observe that we are now using string sequence indexing. We are saying final underscore letter of name of -1. That's simply going to be the last character A here. So the answer for this particular subproblem is going to be A. The next subproblem is asking what is Looney underscore list of 3. Recall that Looney underscore list is part of the global frame. That's going to take us to this crazy list over here. The third index position is simply a self-reference to the same list. So we can comfortably strike out loony underscore list of 3 reference. What is loony underscore list of -1? That's just a different way of mentioning the indexing for the same self reference here. So we can strike out all of the indexing which use 3 and -1, and that's going to get rid of majority of the indexing for this problem. Then we are saying loony underscore list of 0, that is simply going to be the integer 8 here. The final subproblem is asking us what is Webster of L. Webster is part of the global frame here. Let's keep track of the arrow that's taking us to this particular dictionary over here. The key L corresponds to the value of this particular crazy list. So Webster of L of 2 is simply going back to the Webster dictionary on the top here. So Webster of L of 2 is simply nothing but Webster. So we can strike out the combination of L key lookup and the indexing for 2 here. So I'm going to strike out all the L key lookup and then the indexing 2. Finally you have Webster of L, which is taking you to this particular list. Within that list you're indexing into position 1, which is going to be the value 9 here. Please make sure to go through the rest of the problems as part of today's lecture worksheet. I would also encourage you to type this particular program into Jupyter Notebook and verify each of the sub-problem answers. Actually, instead of using Jupyter Notebook, Python Tutor might be a better way to verify the answers because you will be able to see such a visualization. I'll wrap up this video here.